Hello and welcome to this learning video. In this learning video, we are going to start with a brand new topic named as linear differential equation of first order and first degree. So, the linear differential equation of first order and first degree has its application in motion of rising or falling of an object in air resistance. It also has an application in finding out the current in an electrical circuits, and the application of finding currents with the help of this linear differential equation, we are going to take it at the end of this unit. Okay, so let us start with this linear differential equation. So a linear differential equation of first degree, first order and first degree of the form like this is a linear differential equation. Okay, and this P and Q, are functions of x only or just constant. It is written there, already written. Okay, so no need to write it down. These are functions of x and these are just functions of x, and sometimes in place of this p and q there would be some numbers or some constants. Okay, now this is the linear differential equation of type 1. Now in this topic we have three different types of this linear differential equation. First one is this type, then type 2 and type 3 that we will take in the next half of this topic. So type number 2 is differential equation of the form dx by dy plus p into x is equal to q. This is type 2 of differential equation where this p and q are functions of y only or they are just constant, that we shall take in the next learning video. Okay, and this type number 3 is an equation of the form x dy by dx, or it would be like say r dy by dx plus s into y is equal to t. So this is type 3. Actually there are only two types. I am just introducing this type number 3, wherein you will find some function will be attached to this dy by dx, wherein in case number type 1 and type 2 the coefficient of dy by dx or the coefficient of dx by dy is 1. Okay, sometimes it may be a function of x in front of this dy by dx, so you need to divide this function. So I am taking this as a type number 3 in this topic, and the moment you divide this equation by this r, you will be getting dy by dx plus s by r into y is equal to t by r. Okay, so this converted into type 1. So type number 3 equation of the type 3 gets converted to either type 1 or type 2 depending on the given problem, and then we have to solve the type 1 and type 2 type 1 and type 2 of differential equation. So that we shall discuss in the later on. So let us first of all discuss this first part. So this is the first part that we have this linear differential equation of type number 1. Okay, so if this is clear to you, then we can talk about the working rule. So what is the working rule? The working rule is very simple. Working rule. So the working rule comprises of some steps which would be handy in solving the problems. Okay, so the very first step that you can write in this is write the given differential equation of the form this dy by dx plus P into Y is equal to Q. Okay, so first of all you have to arrange the equation and try to write like this. Then the very second step of the working rule says find out the integrating factor. Find out an integrating factor. And what is that integrating factor? That you have to remember. The integrating factor, which we denoted by IF, is equal to e to the power integration of P dx. This is the integrating factor. Okay. And the third one is, the moment you found out the integrating factor, just write down the general solution. The general solution of given linear differential equation is given by, what is that? Y into integrating factor, y dependent variable into integrating factor is equal to integration of q of x. This q we haven't written, q of x, so this is q into integrating factor dx, okay, plus the constant term. So this is nothing but the solution of this type of linear differential equation. For the time being we are just discussing type 1, so this is the working rule for type number 1. Okay, now to make the idea more clear about this topic, let us take an example on it. So taking an example on this type 1, solve dy by dx minus y tan x is equal to 3 e to the power minus sine of x. So this is the problem given to us and we have to solve this problem. Okay, so first of all see whether this is of the form like this or not. Dy by dx plus p of x into y is equal to q of x. So this is given in the form of this. Okay, so how we can start with? We can start with the given equation. The given equation is, what is it? Write it properly. Dy by dx plus minus of tan x into y is equal to 3 e to the power minus sine x. As you can see, this is the very first example, that's why we are writing it like this. Okay, the moment you would be very familiar with such notations, you can directly write. Okay, so the given equation is this. So this is of the form, what is it? Dy by dx plus p into y is equal to q, where what is p? Yes, what is p? Where p is equal to minus tan x, q is equal to 3 into e to the power minus sine x. Step number 1 is OR. Okay, now step number 2 says find out an integrating factor. Okay, so to make it very simple, what I am going to do, I am going to take integration of e to the power px first and then whatever integration I am getting, I will put it at e power. Okay, so to find out integrating factor, that is my step number 2. Let me find integration of p dx. So what is integration of p dx? Integration of p dx is integration of what is p minus 10x, this one. So minus 10x dx. So this is minus outside. Integration of 10x is log of sec x. Don't write here plus c in the integrating factor. Okay. So minus log of secant x. Okay. Now you can easily write down the integrating factor, right? So what is integrating factor here? Therefore, integrating factor is equal to e to the power integration of p dx, which is e power. What is integration of p dx? Just we have found out, that is minus of log of secant x. Simple. Now this can be written as e to the power. Now apply the property of log. It is like m log a. What is m log a? Property says log of a to the power n. So applying this, it would be e log of secant x power minus 1. Okay. Now you know that these exponentiation and logarithm are inverse of each other. So we will remain with secant x power minus 1. Okay. Secant x power minus 1. Clear? Which we can write it as 1 upon secant x. Right? And what is 1 upon secant x? Cos x. Okay. So this is my integrating factor. Now this is the third step. The third step says the general solution of the given linear differential equation is given by this. So you just need to substitute these values and integrate. So let me rub this now. So what is it? Y. So y as it is into integrating factor cos x is equal to, what is it? Integration of q. What is q? This right hand side term on the right hand side. That's 3 e to the power minus sin x into, again integrating factor, that is cos x dx plus some constant of integration, say c. Okay. Now I can take this 3 outside. Okay. Now this is the integration we have to solve, and this can be solved by using the method of substitution, right? So we use the method of substitution. So whatever substitution we are doing it for the integral. So you can write in the integral, put sin x is equal to t. Therefore cos x dx is equal to dt. Simple, because derivative of sin is cos. So this gets converted to y into cos x, 3 outside, integration of e to the power, what is sin x? T. So it is minus t, cos x dx is dt plus c. Okay. Now you just have to integrate. What is integration of e to the power? Very simple. So integration of e to the power t is 3 e to the power minus t divided by the coefficient of t minus 1 plus c. Simple. Now resubstitute. So when you resubstitute, you will get y into cos x is equal to minus 3 e to the power, what is minus t? So this is minus sin x plus c. Okay. And this is nothing but your solution to the given linear differential equation. Okay, so I hope these things whatever we have taken here are gettable to you, and if you have any doubt you can ask. So thank you for watching this learning video and have a good day. Thank you.